Welcome to DMAX, the distributed manufacturing exchange that connects buyers, creators, and producers to enable distributed, on-demand, trusted manufacturing at or near point of need. Here we see the relationship between the stakeholders of a traditional supply chain that makes things in the wrong place and then ships them to point of need. It is a model that evolved to take advantage of the low cost of offshore labor and is predicated on the assumption that borders will remain open, the cost of transport will remain inconsequential, and that nobody will care about the externalities of shipping goods across vast oceans. It doesn't matter where the creator of a product and the buyer live in relation to each other, because the information that flows between them is digital. Same for the creator and producer, who can exchange digital information at the speed of light. But the connection between producer and buyer is physical. The further they are apart, the more cost, carbon, and complexity are generated each time a product is purchased. So, we asked ourselves, what if we could move the producer as close to the buyer in as many transactions as possible? Well, much of the cost, carbon, and complexity would be cut out of the supply chain, because on-demand manufacturing at point of need would mean resources are only used when they are needed, where they are needed, in the quantity they are needed. DMAX uses a combination of blockchain, NFTs, and physically unclonable functions to ensure that genuine distributed products can be manufactured at the same security, quality, and authenticity as traditionally produced goods. Ultimately, we provide trust and proximity as a service. Okay, so let's see DMAX in action. Our demonstration will play out over this network of 50 geographically distributed production facilities. We're going to start with Jeremy, who is a creator for the Acme Corporation. Jeremy has imported the digital twin of the composite gimbal fairing that he wants to publish to the exchange, but doesn't have a bill of process, which is a key artifact required for distributed manufacturing. He can use the DMAX AI to generate a full BOP from a simple text description and adjust it until it correctly represents the production process. DMAX producers use an edge-based execution engine to interpret the BOP and orchestrate production. The JSON output of the AI BOP generator is natively compatible with that BOP-X engine. All it needs are the machine instructions from the CAD/CAM engineers and any electronic work instructions for operations. Remember, this is a one-time effort that will be used by any compatible factory in the network each time a buyer orders this product. Jeremy can verify whether the operations in the BOP are in the standard ontology catalog and eventually map in any custom capabilities. Remarkably, he can then instantly visualize which factories in the network are capable of producing the design. A facilities manager like Claire oversees the factory network of each producer. Key to the utility of DMAX are the location of each factory and the manufacturing capabilities each one exposes to the platform. Here we see Jabil's Fremont facility, its skills, and how they map to the ontology catalog. Okay, back to Jeremy, who is enriching the product definition with the information required to publish to the exchange. This includes pricing, the level of details in the digital twin exposed to the buyers, marketing descriptions, and artwork, both generated by the DMAX AI, and the options the buyers will have to personalize the product before it is manufactured. This can include alternative materials, in this case a choice between normal and glossy carbon fiber, and certain certified measurements, such as the diameter of drill holes. With the design complete, Jeremy generates and electronically signs a smart contract on the dimax blockchain for the gimbal fairing. This will allow any genuine distributed product to autonomously verify its authenticity. dimax provides enterprise creators like the Acme Corporation control over where each product can be produced. As the supply chain manager, Katie can create multiple subnetworks that include her own and any third-party facility. Before the gimbal fairing is made available to buyers, it must be associated with one or more of these subnetworks. With a single click, Katie can distribute the encrypted manufacturing blueprint to every associated compatible factory, shortcutting a traditionally manual process that requires on-premise re-engineering and weeks of trial and error. Alastair is a buyer. He may be an individual consumer or may represent a corporate entity such as an automotive dealership, a Department of Defense procurement agent, or a local Walmart. He is going to use dimax to identify the producer that maximizes proximity to his location, and so he lets the platform know his current address. We expect buyers to interact with dimax via a Make button in their regular online store, such as Amazon, Walmart, or Nike.com. But here, Alastair has directly accessed the dimax store and is using the inbuilt AI to find the product that best meets his needs. Unlike regular online stores, dimax buyers can try before they buy, interacting with the digital twin of the product, triggering sophisticated simulations, and choosing between the personalization options made available by the creator. Alastair can purchase a virtual copy of the product for use in his digital workflow, or can use dimax to identify his options for on-demand manufacturing of a physical copy. Of the 50 facilities in the demonstration network, the 8 shown in the map have the capability to produce the gimbal fairing, but only 6 are in the Americas subnetwork that the supply chain manager set as a constraint. Alastair can choose the one that provides him with what he considers to be the best blend of speed, cost, and carbon footprint. This is an expensive carbon fiber part, and Alastair must refill his dimax wallet before the purchase will go through. With the transaction complete, an NFT is minted by the creator's smart contract, authorizing the manufacture of a single physical copy by the chosen producer. Helen runs the Flex Node 2 facility in Fremont. She receives the order for the part and downloads the manufacturing package to her secure dimax Edge device, where it is decrypted and executed by the onboard Industry 4.0 production engine, BOPEX. Here we see Alastair's order and associated bill of process ready for production. As soon as resources become available, BOPEX begins negotiating the routing of the order through the facility. For our demonstration, we have accurately modeled an autonomous facility complete with 9-axis robots that perform the automated fiber placement operation, autoclaves that BOPEX configures to cure the part, 5-axis machine tools to which BOPEX downloads the part programs needed to deburr, drill, and probe the fairing, and even the operators who follow the provided electronic work instructions. Because there are no fixed production lines, this so-called decoupled facility can manufacture anything that requires some combination of the skills it provides and the materials it has available. Because BOPEX automates production and uses AGVs and smart conveyors to move the work in process, throughput is far higher than a corresponding manual facility. Each producer is provided with capability coverage reports, allowing the modular equipment to be added or removed on the fly to maximize the chances of being matched to a buyer's request. BopX streams all production results into the dimax traceability blockchain, including the order-specific carbon footprint, which is used to generate a CO2 savings certificate for the creator. A smart contract on the blockchain compares the results to the bill of process and determines if the item can be certified as a genuine distributed product. We use a physically unclonable function, or PUF, to anchor the blockchain results and buyer's NFT immutably to the physical product. Only genuine products are puffed because we only allow a single copy to be printed per item produced. Once the puff is generated, DMAX burns the production package from the secure edge device so that further gray market copies cannot be made. The product can now be delivered locally to the buyer. Alistair can only accept delivery of the product when the puff is read and validated using the DMAX client. This ensures that the item is authentic, matches the ordered specification and quality parameters, and will perform as designed. He can use the NFT to prove ownership until he decides to sell the product on the exchange, at which point the NFT and any remaining warranty is transferred to the new owner. Now the buyer can review the product and producer and share his amazing experience on social media. At DMAX, we believe that reindustrialization requires more than creating a handful of vertically integrated walled garden manufacturers in the U.S. Instead, by connecting buyers to excess manufacturing capacity in the 20,000 small-medium businesses already operating across the country, we can recover the jobs we lost to China and bring a new wave of prosperity and productivity to the American middle class. If you enjoyed this video, then look out for our CPG variant.